Okay, so this says the reaction Q in the gaseous phase reacting with R in the gaseous phase produce Z in the liquid phase, and it's shown to be exothermic. Which of the following is true concerning this reaction? A couple things we want to notice about this reaction. First of all, that we're going from gaseous reactants to a liquid product. So that means that the delta S of this reaction is going to be a negative number, less than 0. And I can say that because I know that gases have more entropy than liquids. And I also have a larger number of moles on the reactant side than I do on the product side. So that leads me to think that the delta S of this reaction, the change in entropy of this reaction, is going to be negative, less than 0. And I'm also told that this is an exothermic reaction. So I know that by definition, the enthalpy change, the delta H, is a negative value. It is less than 0. So those are the two ideas that we're going to use to answer this question. But I also have to utilize this equation. The Gibbs free energy change, delta G, equals delta H minus T delta S. And we're just going to do some analysis with that equation. Remember that the Gibbs free energy change is your indicator of spontaneity. A negative delta G means spontaneous, a positive delta G means non-spontaneous. So from this reaction, we know that we have a negative delta H, it's exothermic. We also have just decided that the delta S is a negative number, okay? And from the equation itself, we have a negative in the equation. And so we know that when we multiply this negative temperature times this negative delta H, that is going to result in a positive number, okay? So I've got a negative term in the equation and I've got a positive term in the equation. And essentially they're competing. If the negative delta H is bigger than the positive T delta S, then we will have a negative delta G and therefore a spontaneous reaction. If we have a larger T delta S term, then the positive term wins out. It will overcome this negative delta H and make the delta G positive, right? So what that results in is this shows the temperature dependence, because what we'll have is we'll have a negative delta G at low temp, okay? Because that temperature, if it's a small number, then that's going to be a small positive number that won't overcome this negative delta H, and so we'll end up with a negative delta G. But delta G will be positive at high temperatures, because this temperature, if it's large, that means that we'll have a large positive number, which will overcome this negative number and turn the delta G into a positive number. Okay, so now knowing that, let's look at our options here and decide which one is correct. But let's remember here that we know that spontaneous means a negative delta G, so this is going to be spontaneous, and then at the high temperatures, because we have a positive delta G, it means non-spontaneous. Well, right here for A says, is spontaneous only at high temperatures? Nope, because I just figured out that that's when it's non-spontaneous. B, is spontaneous only at low temperatures? Well, yeah, I figured that out right there. So I think that's my answer, but let's go ahead and consider the other options. Is non-spontaneous at all temperatures? Well, no, I figured out that it is negative. It is spontaneous at certain temperatures, low temperatures. Is spontaneous at all temperatures? Well, that's not true either, because I figured out that it's non-spontaneous when I have high temperatures. Okay? And then this E is also true because it contradicts what I found out here. It is spontaneous at low temperatures. So I can eliminate those guys as well, and B must be my answer.